Hello students, how are you? I hope all of you are good. In this video, I am going to start the introduction part for the exercise 1.2. So the introduction part of this exercise involves with the concept of functions. And also we need to study the types of functions. So first thing, functions means what? So already you have been studied the definition of functions in PUC first year. So just I want to recall here, the function means definition of what? Function. Functions in the sense, suppose a relation from A to B. A relation from the set A to B is said to be a function. Is said to be a function. If is said to be a function. Is said to be a function. Function. If each and every element of the set A, each and every element of the set A must has unique images in the set. Each and every elements of the set A, each and every elements of a set A should have or must have unique images, must have unique image unique image in set B, in set B, then the relation is said or called a function, then the relation is called function. See here, for example, suppose this is a A set and this one is a B set. This one is a B set. Suppose A consists the elements 1, 2, 3 and B set consists the elements A, B and C. And this relation is defined from A to B. Now, to say this relation is a function, each and every element of this first set A should have the unique images in set B. Suppose 1 has the image B and 2 has the image A and 3 has the image C. Here one more thing I need to say here. Here 1 related to which element? 1 related to B and 2 related to which element? A and 3 related to C. So in the first element 1B, this B is called image of 1. B is called what? Image of 1. And 1 is called as what? Pre-image. 1 is what? Pre-image of which element? B. Same thing, A is image of 2, 2 is pre-image of A, C is image of 3, 3 is pre-image of the C element. See here 1 has a unique image, 1 is related to only one element and 2 related to only one element, so 3 related to only one element. That's why this relation is one of the function. Consider one more example. Suppose this is a set P and this one is a set Q. And suppose P consists the elements P, Q, R and Q consists the elements 1 and 2. Here see it, suppose this P related to 1 and R related to 2. Is this relation defined from P to Q is a function? So what is the condition? Each and every elements of the first set must has a unique images in the second set. But here the element Q which is in P set has no any image in the second set. It means this relation is not a function, I hope all of you are understanding. Consider one more example to understand this. Suppose this is a set X and this one is a set Y. Suppose X set consists the elements X, Y, Z and Y set consists the elements 5 and 6. And in this relation, suppose this element X related to 5 and Y related to 5 and Z related to 6. Now, is this relation which is defined from the set X to Y is a function? So, observe here, in this relation, the element X has a unique image, Y has a unique image and Z also has unique image. It means this relation is also one of the function. Obviously, so X and Y has same image, but these two elements X and Y has unique images. So that's why this relation is also one of the function. This is a function. And first one is also what? This is also a function. Now consider one more example, and which is the last example. See here. Suppose this is a set and this one is a B set, and elements of the set A are A, B, C, and elements of the B set are 1, 2, 3, and 4. So in this relation, the element A related to 1 and A related to 2, B related to 3, and C related to 4. Now observe here, is this relation which is defined from A set to B is a function or not? So observe here, the element A which is in the set A has two distinct images, has more than one image. It means element A which is in the set A has no unique image. It means this relation is not a function. This relation is not a function. Is not a function. I hope all of you understood the definition of the function. And next what? We need to study the types of functions, and here I need to discuss one more thing here. So this relation defined from A set to B set, and where A is called as a domain of the function. Set A is called as domain of the function, and B set is called as codomain of the function. B is called as codomain of the function. I hope all of you understood everything which I discussed in this concept of function. Now what? Types of functions. Now types of functions. Types of functions. So for your class 12, you have basically three types of functions. First one is a one-to-one function. Second one is a on-to function, and third one is a bisective function. So firstly, I am going to discuss what? One-to-one function. So first thing is what? One-to-one function. One-to-one function. This is also known as injective function. This is also known as injective function. See here, what is the definition of this injective function? So one-to-one function means if a function f defined from set x to y, defined from set x to y, which is defined from the set x to y, is said to be one-to-one function, is said to be one-to-one function if each and every element of the first set, if each and every element element of the first set x of set x must has unique unique and they are distinct, unique and distinct images, distinct images, distinct images in set y, then that function is called one-to-one function. Hope all of you understood. See here, any function f is said to be a one-to-one function if each and every elements of the first set has unique and distinct images, unique and distinct images, then we call it as a one-to-one function. Or here, first I'm going to consider the example to understand this. Let's suppose this is a x set. Let's suppose this is a x set, and let's suppose this is a y set. Suppose x set consists of the elements A, B, and C, and Y set consists of elements 1, 2, and 3. Suppose B related to 1, and A related to 2, and C related to 3. Is this is a function? First we need to check whether it is a function or not. Observe here, every element of the first set has unique images, in the second set. So that's why this is a function. Now, is it one-to-one function? Observe here, every element of this first set has unique images, and they are distinct from one to another. A has 2, B has 1, and C has 3 as its image. So they are different from one to another. It means this is one of the one-to-one function. Obviously, that is what? One of the one-to-one function. One-to-one function. Hope all of you are understanding. Now consider one more example here. Let's suppose this is a first set and this one is a second set. Suppose the first set is defined by A and second set defined by B. And let's suppose A consists of the elements 1, 2, 3. And B consists of the elements A and B. And in the first set elements 1, 2, 3, 1 is related to A and 2 related to B and 3 related to B. Now first thing, is it a function? Obviously it is a function. Why? Because every element of the first set has unique images. 2 and 3 has same image, but 2 and 3 has the unique image. So that's why this is a function. Now this is a one-to-one function. So one-to-one means each element of the first set has unique and distinct images. By observing here, 2 and 3 has unique images, but they are not different. 2 and 3 has the same images. That's why this function is not a one-to-one function. Why it is not one-to-one function? Suppose this is a function f which is different from a to b. The value of f of 2 which is equals to f of 3 and which is equals to b. So 2 and 3 has same image. That's why this function is not one-to-one function. Is not one-to-one function. I hope all of you understood this first and second example. Now the second type of function, onto function. Second type of function is what? Onto function, and onto function is also known as surjective function. So other name of the onto function is surjective function. See here, when a function, we call it as an onto function. Suppose a function f from x to y, is said to be onto function, for every elements y belongs to this second set codomain. There must exist an element x belongs to the domain x such that such that fx is equals to y, then we call it as an onto function. So if every elements of the second set has pre-images in the first set, if every elements of the second set has the pre-images in the first set, then that function is called as an onto function. So it means we may also define this onto function as if a function, so a function, are you right? Are you right? A function f from x to y is said to be is said to be onto function if each and every element of the if each and every element of if each and every element of codomain in the sense y set has has pre-images has pre-images in the domain set in domain set x, then we call it as an onto function. I hope all of you understood. If every elements of the second set has pre-images in the first set, then we call it as an onto function. So for example, observe here. Let's suppose this is a first set A set and this is a second set B set. Suppose A set has 1, 2 and 3 and second set has A and B elements. Now we need to check whether it is an onto function or not if a function defined from the A to B. Now observe here, suppose 1 related to A and 2 related to B as well as 3 related to B. Now is this function is an onto function? What is the condition here? Condition is nothing but each and every element of the codomain set must has a pre-images in the domain set. So observe here, A has a pre-image, B has a pre-image, it may be 1 or 2. B has a pre-image. So it means every element of the second set has pre-images in the first set. function is an onto function. It means this function is an onto function. I hope all of you understanding. Let us consider one more example here. Let's suppose this is the first set x and this one is the second set y. Suppose first set consisting the elements 1, 2, 3 and 4 and second set a, b, c and d, and this function is defined from x to y, and one has the image b, two has the image a, three has the image d and four has the image c. So is this function is an onto function. So observe here, a has a pre-image, b has pre-image, c has pre-image, d has pre-image. So every element of the codomain set has pre-images in the domain set. It means this is also one of the onto function. This is also one of the onto function. I hope all of you understanding. And now observe here, let us consider one more example. Let's suppose this is the first set and this one is a second set, and first set is defined by a set and second set is a b set, and suppose first set consists the elements 1, 2 and 3 and second set consists the elements a and b. Suppose this element 1 related to a, 2 related to a and 3 related to a. Now this function is defined from a to b. Is this function is an onto function? First thing, every element of the first set has unique images in the second set. It means it is a function. Is it onto function? Observe here, in the second set b has no pre-images in the first set. It means this is not an onto function. This is not a onto function. I hope all of you understanding. So now see here, to say the function is an onto function, every element of the second set has a pre-images. So it means the set of output values of the function must be equal to codomain of the function. Codomain means second set. Set of output values means here the output values are a and b. A, b. So this is what we call it as range. We call it as range. So range of the first function is set consisting the elements a and b. Is this set equal to codomain? So codomain of the function is what? Second set y. Codomain of the function is what? Y. Here the codomain of the function is b. So definitely it is equals to b. So if range of the function is equal to codomain of the function, then we call it as an onto function. So here also you may observe here the range of this second function. Range of this function is a, b, c and d. So output values. Is it equal to codomain of the function? Obviously equal to y set. So that's why this function is an onto function. Now in the third question, observe here, the range of the function is, the range of the third function, range of the third function is only one output I am getting here. Only one output is I am getting here. So what is that? That output is a. So set consisting a is a range of this third function. And is it equal to codomain of the function? So what is codomain of the function is b. So b set consisting two elements a and b. So this range is not equal to codomain, is not equal to codomain. So that's why this function is not an onto function. I hope all of you understood the definition of onto function. Onto function is also known as a surjective function. And last type of function I'm going to discuss here only. See here, last type of the function is bisective function. Last type of the function is bisective function. So third type of the function is what? Bisective function. Third one is what? Bisective function. Bisective function. So bisective function means the functions which are one to one and onto. The functions which are one to one and onto are called as bisective function. The function which are one to one and onto functions are known as bisective function. Are known as bisective function. And also you need to remember one more point here. Model in syllabus kittu illa. So you must and should remember this. Bisective functions are invertible functions. Are invertible functions. Invertible functions means the functions which are having inverses. So the bisective functions are always having inverses. The functions which are one to one and onto are known as the bisective functions. And the functions which are bisective, they must have a inverses. That's why bisective functions are known as invertible functions. I hope all of you understood this entire concept. First we studied function, and then one-to-one function, on-to function, and at last what? Bisective functions. And bisective functions are known as invertible functions. I hope all of you understood.